So this is just computational, and you get a little bit of music while you're dealing with it. So this means 3 factorial over 3 minus 2 factorial, 2 factorial. This is combinations. So this is 3 factorial over 1 factorial, 2 factorial. This is 3 times 2 times 1 over 1 times 2 times 1. Gone. So the answer is 3. Okay? This one I just want you to simplify. I'm hoping you can get to the point where when you see this, you're just thinking 6 times 5. Because if I was to write 4, 3, 2, 1, it would cancel this out. Make that a little bit bigger even. So that took care of that, and then I have the 3, which is 3 times 2. And then 6 times 5 is 30, times 3 is 9, times 2 is 180. And I'll teach you later how to use your calculator. 8p3. So 8 factorial over 8 minus 3 factorial. If you want to go straight from 8 factorial, 5 factorial, and skip this step, great. This means 8, 7, 6, 5, 4, 3, 2, 1. This means 5, 4, 3, 2, 1. So I take out the 5, 4, 3, 2, 1, and it's 8 times 7 times 6. 42 times 8, 336. It isn't a word problem, so I'm just getting the answer. This one's a little bit different, and I want to make sure you see it. This means, see how this is in parentheses? So this means 3 factorial. But this means you have to go 9, 8, 7, 6, 5, 4, 3, 2, 1 minus 6, 5, 4, 3, 2, 1. Then divide it by 3 times 2. So I'll go 9 factorial. I don't have a factorial on the simple button, on the simple calculator, but I will show you how to do it in the fancy one eventually. I just don't have access to it. So that is 362,880 minus, I think this is 720, minus 720 over 3 times 2, which is 6. I'm going to go 362,880 minus 720 divided by 6. And I get 60360. Okay? So that's all the computational stuff. Now let's get to the homework. So let's see. All right, we're dealing with a password. So it's 5 digits long, 1, 2, 3, 4, 5. So they're digits. And you can use the digits 0 through 9. 2 of the digits, wait. Oh, 2 of the digits must be letters. So, okay. That's a letter. And that's a letter. These are numbers. These are numbers. And let's see. It looks like I can repeat the numbers. So how many numbers are there? 0 through 9? 10 times 10 times 10. How many letters? 26 times 26. So I just go 26 times 26. 676. 1, 2, 3. 3 zeros. And it looks like passwords. Now, I want to talk to you before I go to the next one. What happens if it said you can't repeat? All right? And I had 1, 2, 3, 4, 5. Number, 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 letter, letter. So I can use all 10 digits. But let's say I use the 7. Well, now if I've used the 7, it's 0, 1, 2, 3, 4, 5, 6, 8, 9, 10. The 7 skipped. So now I have only 9 possibilities. So maybe I use the 7 here and then I use the 3 here. So now I only have the choice here of 0, 1, 2, 4, 6, 8, 9, 10. So I only have 8 options. Then I look at the letters. Well, I have 26 letters to choose from, but let's say I use the letter Q. Well, now I only have 25 letters to choose from. So look at the difference between being able to repeat and not being able to repeat. All right, let's see, next one. All right, looks like we got food, pasta, sauces, 5 choices of meat. By the way, this is the fundamental counting principle, and this is also the fundamental counting principle. I do the fundamental counting principle when I can do something like that. Okay, so that's just 6 times 4 times 5. 6 times 5 is 30. Times 4 is 125 dishes, or 120 dishes. Okay, that's how many options I could choose from. Okay, if you ever go to a pasta bar, look at all the different choices you have. All right. It looks like they're talking about pasta again, but all they're talking about is pasta. So fundamental counting principle is out. So if he chooses 3 pastas from the 6 that are offered, how many difference does he have? That's combination, because whether I pick linguine and then angel hair, or angel hair and then linguine, it's all going in my dish. So that would be 6C3. That means I go 6 factorial, 6 minus 3 factorial over 3 factorial, which is 6 factorial over 3 factorial, 3 factorial. Remember, I don't need this step. This is really 6 times 5 times 4, 3, 2, 1, bye-bye. Over 3 times 2. Simplify it however you want without a calculator. 3 times 2 is 6, so I get 20 dishes. Okay, 20 different dishes. All right, let's see. All right, this one reminds me of the one on the previous page. There's a president, a vice president, a secretary, and a treasurer, so it matters. If student A is president or student A is treasurer, that's different. That's permutation. I have 10 students and 4 positions. 10 factorial over 10 minus 4 factorial, which is 10 factorial over 6 factorial. You can skip this step, which is 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. Okay. 8 times 9 times 7, 5, 0, 4 times 10, 0 ways. Okay. Looks like, ooh, this one's a little bit different. Rhonda created 6 different desserts for each of her 6 friends. If she closed her eyes, what is the probability she gives the right dessert to each of her friends? So here's the deal. There's 6 different desserts. This is the fundamental counting principle because you're using all the desserts. Now, each person A, B, C, D, E, and F, all like a certain dessert. So if person A likes dessert Q, but you give it to B, they're not going to be happy. Okay? So there's a 6%, there's 6 chances that you'll get this one. But let's say, okay, yay, person A liked dessert Q. Cool. Well, now the Q has been used. So let's say the desserts are this. Q, R, S, T, U, V. 1, 2, 3, 4, 5, 6. Okay? And let's say person A likes dessert Q. Well, that means now that person B only has 5 choices left. And person B liked R. So we got it. Yay. Now it's person C. So far, we've got to make sure everybody has the right dessert. And then 4, and then 3, and then 2, and then 1. Because there's only 1 dessert left by the time you get to F. It has to be V. Okay? So 6 times 5 times 4 times 3 times 2 times 1 is 720. But here's what's different, and I haven't quite taught it to you, but I will be teaching it to you tomorrow. Probability. Probability means what's the chance of it happening. Well, there's only 1 chance out of 720 options that you could get the perfect dessert. So when you're dealing with probability, you'll notice you get a fraction as an answer. Because it's like, what are the chance? What's the percent it's going to happen? All right, let's simplify this. This means 6 times 5 times 4, 3, 2, 1. This means 2 times 1, 5 times 4 times 3, 60. This is 6 factorial. Look how they're similar. 6 minus 3 factorial, 6 minus 3 factorial. But this one, since it's combination, it has less choices, which means you need to divide out more. 6 factorial over 3 factorial, 6, 5, 4. That's 120 for permutations. This is 6 factorial over 3 factorial, 3 factorial, which is 6, 5, 4. Covers that, like it covered that. But then this is 3, 2. 3 times 2 is 6. Look how many less ways when it really doesn't matter. Isn't that true? The more high maintenance people are, or at a moment, the more difficult it is, the longer it takes. But if you're like, yeah, whatever, sounds good, it's less.